Good morning. In this lesson, we're going to learn more about angles, how to label them, so the correct use of angle notation, and we're going to learn how to measure them using a protractor. As you can see, I have 3 angles here, and they're labeled differently. And it's important that we know how to describe these angles in each of the different ways. Let's take a look at this first one. We can see that the angle that we're trying to measure is in between these 2 arms meeting at this vertex here. And it's the inside where this arc is showing that helps us to know that we want the measure of distance in between those 2 arms rather than the distance on the outside or the exterior. And it's this arc that's helping us to know that we want this inside and not the outside. And this time we have been given a capital letter to label this angle. So this is the angle A. And what's really important when we look at how we measure angles is that we always estimate, first of all, what we think it might be. And we can use our knowledge of what the different types of angles are that we learnt in our previous lesson. So I can see that this is definitely bigger than a right angle. It's bigger than the corner of your book or your page, and therefore it's an obtuse angle. So that means that this will measure somewhere between 90 degrees and 180. So maybe something like 130 degrees. And this will help us then, when we actually measure the angle, to see that we should be getting somewhere around that estimation, between 90 certainly and 180. So I could write down my estimation like this. It's obtuse, and we know that that means that the angle A, so A must be between 90 degrees and 180 degrees, and we can use the less than symbols to show that. So 90 degrees is less than our angle A, but the angle A is also less than 180 degrees, and we could pick anything that we think is approximately correct. So I'm going to take 130 degrees. Let's have a look at this angle. Now this time, we haven't got any label inside our little sector. We can clearly see that we have 2 arms. This one arm at the bottom is a line segment, as there are 2 endpoints, C and D. This top arm is a ray, because there is one endpoint C, but the other end goes through B, so it's not an endpoint. And that suggests then it goes on forever. So this angle has been created from the measure, the distance between a segment, a line segment, and a ray. Now we can label this angle then from the path that it takes. If I was to start at one end of an arm, so let's take the ray, and I'm going to travel through the point B to C, C being the middle letter, being always at the vertex, so the middle letter is the vertex, and then it travels down to D. So it goes the path B to C to D, and that helps us know that we want this angle measurement in between those 2 line segment and that ray, those 2 arms. So this is how I can write down my description, my notation of my angle. It's the angle, so we have a tiny little angle to show it's an angle that we're talking about, and it's angle BCD, the path from B to C to D. Now looking at this, we can see that it is much smaller than a right angle, so it's an acute angle, and we know that that means it has to be less than 90 degrees. And taking a good look at it, my estimate, which of course is just an approximation, is that it might be around something like 30 degrees. Or we sometimes have a number inside the angle. So this angle has been labelled with the number 1. And we can see that yet again, this is another acute angle. It's less than right angle, it's less than 90 degrees. The only difference between this one and this one is that this has the vertex at the right hand side and this has the vertex at the left. And that's going to help us later on when we learn about using a protractor and why there are numbers that go around the outside and numbers that go in the inside. And that just is whether we're going to have the vertex on the left or the vertex on the right. That's the reason why we have these two sets of numbers on a protractor. So we're going to use our symbol for our angle, angle 1 then, and we know that that's acute. Now we're going to bring back something that we learnt in the previous lesson, where we use these two little lines going down. And that means the measure of anything inside those two lines. So the measure of angle 1 is less than 90 degrees. And my estimation is it looks like it might be around 40 degrees. So in an exam or a test, you might have questions that look something like this. So angle 1, or the measure of angle 1. We can see that we've got angles because of the little symbols for an angle. We've got the measure of as these two lines, and in between then we've got angle 1, angle BCD, and angle A. So each of these three are ways of us understanding that we're being asked to measure our three angles. Angle A, angle BCD, which of course is also angle DCB. That creates, it's still talking about the same angle, it's just going from this arm to the vertex and then following the ray. So it doesn't matter whether it's BCD or DCB, but the middle letter will always stay the same, and that's the vertex, and that's where the angle will sit. So to measure our angles, we're going to use our protractor, and it might look something like this. There are full circle protractors, which go all the way from 0 to 360 degrees, and there are also some protractors that have the middle part taken out, but they all do the exact same thing. So let's have a look at our protractor. Let's look at some important parts. You'll see that there's a little small bubble surface, a little circle here in the middle, and it has a really important point of intersection. Can you remember what that means? It means where two lines or line segments or rays, where they cross. So we see this cross, and the very, very point where they cross, that's really important. That's called the center mark or the center point. And when we measure our angles, we always have to place our vertex of our angle, where the two arms of the angle meet, onto exactly that center point. Now, the other important part is this line at the bottom, which continues on from our center mark, and we call that the baseline. And that's really important too, because we have to line up the bottom or one of the arms of our angle so that this baseline is exactly over the top. So the vertex will have the center mark exactly over the top of it, and the baseline will be exactly over one of the arms of the angles. So let's just practice lining up our angle before we start measuring it. So we have to have the vertex. So if I'm measuring BCD, my vertex is the point C. And my center mark then has to be exactly over the top of that. And then my arm of my angle, so the line segment CD, you can see that the baseline of the protractor is exactly on top of that too. And that means that we have lined up our protractor and that we're ready to start measuring. The most difficult part with measuring angles is making sure that we use the right numbers. You can see that there are two scales, two sets of numbers. There is an outer scale, so the numbers furthest on the outside of the protractor, and they go from the left, 0, all the way up to 180. And then we have an inside set of numbers, a scale, again going from 0 to 180, but in the other direction. And that's simply because sometimes if your angle, the base or the arm of your angle goes to the right of the vertex, then you're going to be using the 0, the inside scale. You're going to be counting up from 0 to meet the next arm. Whereas if we look at this angle, and I just line up my protractor here, you'll notice that once I have the baseline on top of my arm that I'm going to be measuring, the baseline and the arm are exactly in line. The vertex is exactly on the center mark, but this time this arm of my angle is to the left of the center mark. So I'm of course going to be counting from 0 up. We learned about rotation of angles and that acute angles, they're all between 0 and 90. So it's started with a null angle and it has opened up. And therefore we're going to be using the outside of the angle. So what we're looking for is we need to decide, are we using the inside or the outside numbers? So we pick the scale where the bottom arm of our angle, providing the baseline is on top of it, it's passing through the 0 and we count up from 0. So I'm going to be using the outside scale when we measure angle 1, and then when we're measuring BCD, it's the opposite direction. I'm going to be using the inside scale, again, counting up from 0 each time we do it. Okay, it's time to measure our angle BCD. So we have lined up our protractor properly. The center mark is exactly on top of our vertex C. Our arm of the angle CD has the baseline of the protractor exactly in line with it on top. So let's decide which scale we're going to use. We're going to be using the scale where the arm of the angle that the baseline is on top of passes through the number 0. Well, you can see that 0 is here, and that's the inside scale. So we're going to be counting up from 0. Now, we can see that there are little dashes on the outside of the protractor, and there are 10 in between each number. Each dash, therefore, represents 1 degree. So all we need to do is we need to look at what number then is exactly level with the top arm of our angle. And you can see that it is this dash here. Now 30 is this one, and it's 2 less than 30. And that means then that our angle BCD is 28 degrees. There are 28 little dashes from the 0, from the bottom arm of our angle, and the top arm. 28 degrees, and that's quite close to our estimate of 38 degrees. Let's measure angle 1. So again, it's important to line up the protractor correctly first. The vertex and the center mark are in line. The bottom arm of the angle and the baseline are in line. Let's see where the 0 is. There it is. So we're going to be counting up from 0. We're going to look at what marker our top arm of our angle is at. And you can see that it is at this slightly larger dash in between 40 and 50. And that helps us to know that it is exactly halfway. Each time there is halfway between 30 and 40 or 40 and 50. So each time there is another 5 degrees, the dash is slightly bigger. And that helps us to immediately be able to spot that it is halfway, it's 45 degrees. Now our estimate was 40 degrees, so that's not far off at all. And 45 degrees is definitely an acute, and that helps us feel confident that we have the right measurement. Lastly then, let's measure angle A. So again, center mark is above the vertex, and the arm of our angle has the baseline exactly over the top of it. We need to see where the 0 is that passes on that bottom angle arm. So here it is. So we're going to be using the inside scale. We then find what number or dash the other arm is level with, and you can see it's exactly there. Now, remember we're using the inside scale, so we're certainly not going to say 45 degrees. Remember, this is obtuse. We're using the inner scale because we're counting up from 0. And therefore, this dash here, it's halfway between 130 and 140. It's 135 degrees, which again is quite close to our estimate of 130 degrees. So in our answer to our test or exam, this is how we would show our 3 answers. So the measure of angle 1 equals 45 degrees. The measure of angle BCD is 28 degrees. Remember the little small circle in the top right-hand corner. And it has to be small enough that you don't accidentally mistake it for a 0. And the angle A, the measure of angle A, is 135 degrees. Now it's just as important that we write these notations as part of our answer, not just the measurement 45 degrees. So that's it. You've learned how to use a protractor to measure our angles, and you've learned how to notate them carefully. So let's just recap with our protractor. The center point or the center mark is exactly here. The baseline is the bottom line that we line up our arm of our angle with. And we've got 2 scales. The numbers on the outside is the outer scale, and the numbers on the inside is the inner scale. And that's simply just on whether the angle is going to the right of the vertex or it's pointing to the left of the vertex. One last thing before we go, just for fun. Which king loved fractions? Why, it was Henry VIII, of course. Thanks for listening. See you next time.